Okay, there's some net ionics that we're pretty comfortable with from first year, like your basic synthesis reactions or combustion reactions. Combustion reactions are only hard if you don't know your organic functional groups. That's going to be the only thing that's going to get you on the combustion reaction, so make sure you review those. We also know double replacement, which is just going to end up being us using the solubility rules to get that net ionic. So you'll probably have some spectator ions that'll cancel out. We're pretty good at the redox one. So the redox comes if you have two metals or metal ions and you just use the reduction table. So I have an example for you. It says a strip of magnesium is added to solution of silver nitrate. We don't care about the nitrate because it's not going to make something, it's going to dissolve even when it's with magnesium. So it can't be just a single replacement. That means that we have magnesium solid plus silver metal is going to make something. And you can actually just use your table to tell you what this is going to make. Magnesium is down here. We have the reverse, so it's going to make magnesium plus 2. And silver is going to make, just look at your table until you find silver, and silver's here. It's going to make silver solid. Okay, and then you need to balance the charges, so we're actually going to need 2 here and 2 here to make that one balanced. So that would be how you do redox. If it's a more complicated, remember you balance the O's with H2O, the H's with H+, then the charge with electrons, and then you add them together and simplify. There are 2 special cases that might come up in redox, but it's doubtful. If you have an alkali metal, so here we had magnesium, which is an alkaline earth, but if you have an alkali metal, it will actually plate out hydrogen before any of the alkalis because of what hydrogen's reduction potential is. Okay, so that would be a special case, and if it says electrolysis, that means the solid breaks into its ions. Okay, these ones, they're happening spontaneously. The electrolysis, we're adding energy to make it break down. So those are basic ones that we're pretty familiar with. We're also pretty familiar with acids and bases. We know if there's a strong and a strong, it's going to make either solids or liquids. So here, barium's going to go with chlorine, and H is going to go with OH. Barium chloride is soluble, so that means this net ionic would be H plus OH minus makes water. Okay, barium sulfate is not. So this net ionic, we're going to actually go with, you could have Ba plus 2 plus SO4 minus 2 makes BaSO4. And actually, now that I'm sitting here looking at it, we should probably also include H plus OH minus makes H2O. Because BaSO4 is a solid and H2O is a liquid. And we have to include solids and liquids as being different things than aqueous ions. If there's a weak strong, the weak stays together as the reactant and the strong is the spectator. So here we have the acetic acid and OH, so CH3COOH plus OH minus makes water, and CH3COO minus. Okay, the last acid-base one we're familiar with is hydrolysis. So say you had solid sodium carbonate, you have to keep it together because a solid is different than aqueous, plus water. The Na is going to go with the OH, and the CO3 is going to go with the H, but it's H2CO3. Now, the NaOH is actually soluble, so your final answer should look like this. The carbonate is weak, so it stays together. So in a hydrolysis, if you make 2 weaks, then just keep them together as a product. And if you make 2 strongs, then they should both be dissociated. So that's most of it. I'm going to make one more video because this one's getting kind of long that goes over some special case single and double reactions.